Hi, Pathway people. Mr. Klein here. Today we're going to be talking about something called hypothesis testing. I'm going to be doing this lesson through a PowerPoint. However, I would like you to write down the important parts of the lesson, and I'll try to point those out as we go. So when we check your notes in a couple of weeks, we will be looking to see that you have a heading called hypothesis testing and that you've written down the important parts. All right, here we go. This is your lunch. That's what you ate for lunch. Look at that burger. I have a fun fact for you, and that's that the US Department of Health recommends that people consume 2,000 calories per day. And I'm looking at that burger that you ate. I'm thinking you probably ate 2,000 calories at lunch. So I'm going to make a little hypothesis. What is a hypothesis? A hypothesis is a claim that can be tested. And the claim that can be tested that I'm going to make is that you eat too much. Now, I'm just basing it on that burger that I see in front of you there. All right. So let's look at how we test this claim. Well, it turns out that when we hypothesis test, we really write two hypotheses. This you want to write down, by the way. The first is called the null hypothesis, and we use these symbols H with a subscript 0. And the null hypothesis is going to say that the situation is normal and nothing unusual is happening. The other hypothesis is called the alternative hypothesis, and we write it as an H with a subscript A. And it says that something has changed. Either something is larger or something is smaller or just that something is different. So in the case of the claim that I made that you eat too much, here's what our hypotheses would look like. Our null hypothesis would be that you don't eat too much, or in other words, that you average 2,000 calories per day, which is the US Department of Health's recommendation. The alternative hypothesis is the one that you eat too much, or that you average more than 2,000 calories per day. So you can see how the null right here is that the situation is normal, you're eating fine. And the alternative is that there's a problem, you eat too much. Okay, so those are our two hypotheses. Rather than having to write all of this all the time, what we prefer to do is to use some of the notation we've learned. So another way that you could write this null hypothesis is that mu. Now, mu is a population mean. And so in this case, mu would be the mean of all the days where you've eaten food in your entire life. We're saying that that mean is 2,000. And then the alternative hypothesis would be that mu is larger than 2,000 because we're saying you eat too much. All right, so two hypotheses. Now, a couple of rules about those hypotheses. And I'd like you to write this down too. The first is that for the null hypothesis, you always use an equal sign. Okay, nice and easy, same every time. For the alternative hypothesis, however, there's some options. It could be a greater than symbol, it could be a less than symbol, or it could be a not equal to symbol. And let's talk about the different cases. Okay, so one thing that we might test that we've already talked about is that you eat too much. But another thing that we could test is that you eat too little. And a third thing that we could test is that your diet is just different. Well, these three situations, too much, too little, and different, they correspond to the three kinds of alternative hypotheses that we could have: greater than, less than, or different. Can you guess which symbol goes which thing that we're testing? So too much would be the mean is greater than 2,000. Too little would be that the mean is less than 2,000. Different would be that the mean is just not 2,000. Now, the reason that these symbols are eventually going to be important is that it determines the way we actually do our calculations. If it's too much, then you're going to be finding a right side calculation using Staplet. If it is too little, you're going to be using a left side calculation that looks like this. And if it's a different or a not equal to, you're going to be doing a two-side calculation where you're going to find something above and something below. Okay. So it would be a good idea to have this written down as well in your notes. Now let's work through an actual example. So step one was to write your hypotheses. Step two is to gather a sample from the population. You should probably write down that that's step two, but you don't need to write down all of this. Okay, so those were our hypotheses, which we already had. Now we're going to have to know some things to run this test. So specifically, we know that the mean is 2,000 calories per day. We've already talked about that. We're also going to need to know what the variation is like. And so in the case of this situation, let's assume that the standard deviation of the population is about 300 calories per day. That's a normal amount to vary. Okay. So with that in mind, those things come from the population. We would need to gather a sample. So let's suppose that your sample is that for 7 days, we tracked the number of calories that you ate each day. And we came up with an X bar. Remember that X bar is the sample mean. That's equal to 2,250 calories per day. Okay. So there's our sample. What do we do with it? This I would like you to write down. Once we've got our sample, we're going to calculate something called the test statistic. Now, I always think that the words test statistic are kind of intimidating. No one likes tests, and not all of us are fans of statistic. So you put those two words together and it seems like it's going to be hard, but it's really not. It's just a fancy word for finding the z-score. So to find the z-score, you're going to need these 4 pieces of information. Go ahead and write those down. And what you're going to do with them is you're going to plug them into the formula that we've been working with for the last number of days in class, which looks like this. The z is equal to your sample mean minus your population mean divided by sigma over the square root of your sample size. So in the case of this problem, that would look something like this. I plugged in the X bar here and the population mean here, the population standard deviation here, and the sample size inside the square root. I simplified that to find that we're 250 calories above the population average. This is how much a normal amount of variation would be. Or in other words, I got this from doing 300 divided by the square root of 7. When I divided those, I got a z-score of 2.20. Let's think about what this means. This is saying that the amount that we ate over these last 7 days, it is 2.2 standard deviations greater than what you would expect if we were eating a normal amount. Okay, so that's pretty big z-score, right? Well, what do we do with that? We calculate the p-value. Now again, p-value is new terminology today, but it's something that you've already done. The p-value is, if the null hypothesis is true, it's the probability of getting a sample that is as extreme as the one we got or more extreme. So in this case, it would be the probability of getting a z-score that is 2.2 or larger. So how do we calculate the p-value? The same way you've been finding the probability for the last bunch of days. You go to Staplet, say mean of 0, always 0 there, standard deviation of 1. There's our standard normal population. Now for this one, I'm going to choose to calculate an area to the right because we're testing the hypothesis that you eat too much, and too much is greater than. I'm going to put in our test statistic, or our z-score here of 2.2, calculate the area. It's going to give me a probability. It gave me a probability of 1.39%, and that is your p-value. So the moral of the story here is the thing that you've been learning for the last couple of classes, finding probability. It now has a name. It's called the p-value. Now, what do we do with that? I would say that this last piece is the most difficult part. By the way, if you didn't write down step 4, please write down step 4. And then move on to the last step, step 5, which is to state your conclusions. Now, when we state our conclusions, we're really asking this question. Do we have evidence to reject the claim made by the null hypothesis? Please write this down as we go through. So the null hypothesis was that we eat a normal amount. And have we showed that there's evidence to reject that claim? Well, here's how you decide. If your p-value is small, if your probability is small, and by small we mean smaller than 5%, you're going to reject the null hypothesis. And you're going to say there is sufficient evidence to support whatever the alternative is. If, on the other hand, your p-value is large, and large is 5% or bigger, then we say we fail to reject the null hypothesis. So we're not saying that the null hypothesis is true. We're just saying that there's not enough evidence to reject it. It's sort of like when someone is on trial, they are always determined to be guilty or not guilty, but never proven innocent. This is the same idea. We either reject the null hypothesis or we fail to reject it. Okay. If we fail to reject it, then we say there's not sufficient evidence to support the alternative. So here's what that would look like in our example. We would reject the null hypothesis because the p-value was equal to 0.0136, right? We got that off of Statlet, which is smaller than 5%. So that's the first statement you would make. That's a very statistics-y statement, very technical. Your second statement is going to put it into kind of real-world terms. So your second statement would be this. There is sufficient evidence to conclude the alternative hypothesis, which is that you eat too much. So let me emphasize that one more time. Your first statement, when you're writing your conclusions, is going to look like this one right here, and it's going to be very technical. Your second statement, the one right here, is going to put it into real-world terms. So there it is. There's your first hypothesis test. Now, what I would like to do is go through a couple examples of what it would look like if we had slightly different hypotheses. You don't have to write these down. You might want to, because they might be helpful later on, but I'd at least like you to watch as we walk through them. Okay. So let's suppose we were testing the claim that you eat too little. If we were going to do that, what would change is first our alternative hypothesis would become that mu is smaller than 2,000. In step 2, our mean and our standard deviation would be the same. I'm going to say, let's suppose, because this will make more sense in context, that when we ran our sample, you were actually below the 2,000. Let's suppose that your X bar was 1,900 calories per day. Then that's going to change the test statistic, or the z-score, that we find in step 3. It would end up looking like this. 1,900 minus 2,000 is negative 100. Divide that by the same number we had found before, and we come up with negative 0.89 as our z-score. So at that point, we would go to here. We would change this to the left. Now we're doing to the left because our hypothesis is below this time. So I would put in negative 0.89 was my test statistic, and it's going to give us a percentage. We're getting, what is that, 18.67. So let's go back to here. Now our p-value looks like this. Note that this p-value is larger than 5%. So that's going to change our conclusion. This time we're going to say, failed to reject H naught because the p-value is larger than 5%. So there's our technical statement. And then to put that into real world terms, we'll say, there is not sufficient evidence to conclude that you eat too little. Okay. Doesn't mean that you don't eat too little. I mean, your average was below average. Just means that there's not evidence to conclude that you definitely eat too little. Okay, let's do one more. Let's test the claim that you eat a different amount or that your diet is different than normal. So in this case, your alternative hypothesis would be a not equal to. And let's keep everything else the same. Even your z-score is going to be the exact same. If I keep this at 1900 calories, your z-score will be negative 0.89. But here's the thing that happens that is different. When you run a two-sided test, you need to come here to Statlet and choose outside the region. Your left boundary is going to be the negative 0.89, and your right boundary is going to be the 0.89. And then you calculate your area. So it's going to give you two equivalent areas on either side. One way that you could find this would be just to find the probability that we found before and double it to get the one over here. The idea is that since we came into the test not really having a sense of whether you should be above or below, whatever score we get, we test the probability of getting on either side. So this one and this one. This would give us a probability of 37.35%. So in conclusion, for this example, we get a different p-value because we've run the two sides, but our conclusion is going to be the same because we're still above 5%. So there's walking you through the basics of hypothesis tests, a tool that we're going to be using throughout the rest of the year. Go take a look at your assignment.